So everybody, anytime, so listen to this rule. Anytime you're multiplying 3 polynomials, you should multiply 2 together, combine like times, multiply in the third. Now listen to this though. If you're multiplying 4 polynomials, multiply 2 together, combine like terms, and then multiply that together. Does that make sense, everybody? Multiplying 4. Okay. So then you would do your x minus 2 times x minus 2 times x minus 2, because you wouldn't break the forbidden rule. Then you'd say, I gotta focus in sections. Multiplying this out would be x squared. Notice I draw my lines in as I go, not draw them in, because then you miss things. X squared times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2. Combine like terms, so you have x squared minus 4x plus 4, right? Now that times x minus 2. So then from there you would then distribute, being very careful here. So you have x squared times x, which is x cubed, x squared times negative 2. And then, guys, watch what I do. I've distributed that through to both terms, so I'm going to cross it out. Negative 4 times x, negative 4x times x. Negative 4x times negative 2. Very good. Positive 8x. And then I've taken care of that, so I'll cross that out. Positive 4 times x. And then positive 4 times negative 2. And then you'll combine like terms. X cubed, any other x cubed. Nope. Negative 2x squared minus 4x squared is negative 6x squared. 8x plus 4x is plus 12x. Minus 8. And done. Any questions? Very good. So we would name this, good point, it's a cubic polynomial of 4 terms, right, everybody? Okay, cool. Now, everybody, we're going to review what we learned last time, and then we're going to make sure to finish up 2-1 real quick. Multitask. So last time, we learned about degrees of polynomials and turning points, and we learned formal notation and informal notation for end behavior. So everybody, remember, if you have an even degree, you have the same end behavior, up and up or down and down, right? If it's positive, it's up and up. If it's negative, it's down and down. Positive people smile, negative people frown, right, everyone? Then odd has opposite end behavior. I just said it, odd and opposite. If it's odd, it has opposite end behavior. Now, if it's like a positive in front, then that's going to look like a positive line. And I'm drawing in the air a positive line right now. Isn't that down and up? If it's negative in front, it'll be like a negative line, which is up and down. Does everybody see? So let's review this. Just look up here, don't write or anything. So it's odd, so it's opposite. It's positive, so won't it look like this? So my end behavior is down and up. I'm just going to write this because we're hurrying. How many turning points at most could this have? 2? Or it could have 0. Now, if I said to you, okay, now how many does it actually have? You would then graph it in your graphing calculator and look at it and say, oh, well, this one has 2. Because remember, there are cubics that look like this, and there are cubics that look like this. 2 turning points versus 0. I wouldn't expect you to know what if it had actually 2 or 0 without graphing it on your calculator. All good? Okay, let's do this one. It's even, so it's the same end behavior. It's positive, so it's up and up. And then my number of turning points at most. 7, 5, 3, 1 turning point. Very good. All right, it's even and it's negative. So it's down and down. How many turning points at most? 11? Very good. All right, looking at this one, it's odd, so it's opposite. It's negative, so it's up and down. Very good. And then it could at most have. Okay, cool. Now we've got to extend our knowledge and think a little bit more advancedly. Now we're going to go a little backwards. So everybody, now I'm making you think a little bit more critically. In fact, other teachers took these ones off the homework because they thought they were too hard. They're not. So let's all think a little bit more critically. Everybody, it is up and up. We know it must be even, correct? Yeah. Okay, now let's count how many turning points. 1, 2, 3. This one's not on your worksheet, so you're just looking up here. 1, 2, 3. It has 3 turning points. So what's the degree? 4, right, everybody? So it's x to the fourth. Now, so it says, I'm sorry, I didn't even read the directions. It says, determine the sign of the leading coefficient. So that means, is the leading coefficient positive or negative? And then it says, and what's the degree of the polynomial? So do you see how we figured out it's degree 4? And now, is it positive in front or negative in front? Positive, because it's up and up. You're right. So you just say it's a positive number. You don't know what number it is, but it's positive. All good? Let's do this one. It's odd degree because it's opposite end behavior. So how many turning points? Right? So there's 2 turning points, so it's degree 3. Right, everybody? Is it positive in front or negative in front? You're right, because look, the end behavior looks like a positive line, doesn't it? Down and up, so it's positive. Not too bad. Let's do a couple more. So let's see here. This one's even, so we know it's an even degree because it's the same. 1, 2, 3, 4, 5 turning points. So it's degree 6. Is it negative in front or positive? Negative, that's why it's down and down. Very good. Okay, what degree? Sorry, no turning points here. It's odd though, for sure, right? So let's kind of go in order. The first odd degree is 1. The next one is 3. Is it degree 1? No, because that would be a straight line, wouldn't it? A straight line, right, with a perfect slope. No, it's not a line, so it must be degree 3. So it's x cubed. And then is it positive in front or negative? Doesn't it have end behavior like a negative line? So it's negative. Okay, only a couple more, then you'll do the ones on your homework. What's the degree here? X to the first. Positive? Awesome. Now careful here, because how many turning points does this one really only have? 1. Is it degree 2? No, because degree 2s are perfect use. Now, you've got to be really careful, because a 2 will be perfectly symmetric around the axis of symmetry, which will be located through the vertex. So you've got to look really carefully. Is it perfectly symmetric on both sides? Okay, well, obviously this one's not, right? So it's not degree 2. What would be the next degree it could be? 4. So it's x to the 4th, which, think about it, we talked about how it has 3 or 1 turning point. So that works. And it's positive in front. All good? To do the ones on the homework, yes. So we're going to do the least degree possible. So you're right. How do we, we're just going to do the least degree for this instead of the highest degree it could be. Because it could be technically 8. It could be, you know what I mean? I see what you're asking. Very good. Okay, do 36 through 38 on 2-1. Finishing up 2-1 today first. Up here, but we're going to need it shortly here. Okay, everybody, we have to know the difference between max, min, increasing and decreasing intervals, domain, and range. So everybody look at this with me. It's really quite easy. Okay, here we go. So everybody, do you see how this is my maximum value? It's the highest point, so my max is -3 up 3, right? Now my min is technically, there's no min for this one, right? It's technically negative infinity. So our min, we would just say, we're talking today relative min, relative max. So relative to the graph, do you see how there's no min? So we would say no min on this one. You don't need to take notes, just watch. And then increasing, this is where people mess up every time. Okay, increasing is, where is your function increasing over intervals of x? So it's always x values. So I'm going to first of all write, this point was over -3 up 3. Okay, so right here is a line here. So if I am coming in hot, from -infinity, boom, I hit this point and I'm no longer increasing. Does everybody agree? Increasing would be walking uphill. Do you see how I'm walking uphill? It doesn't matter that it's up at 3. I'm talking x values for increasing and decreasing. So our increasing, we say, from -infinity, because it's x values, do you all understand? -infinity up to -3. Did you all see that? We just tested on this in honors, and the people who got it wrong were people who put the y value. Decreasing is for x, same. We're talking increasing and decreasing is for x. So then after that point, we start decreasing downhill, downhill, downhill till we go to infinity. So at -3, we then grew to infinity, and that's where we were decreasing. Does that kind of make sense? Yep. All good? Okay, now let's do domain and range. So domain is where's my function growing from left to right. It does not matter that it's growing down for domain. Change your eyeballs left and right. Where's your function growing from left to right? -infinity to +infinity, or all real numbers, right, everybody? Now range is the lowest y value to the highest y value. Not even relative. Completely the whole graph. What's my lowest y value? Negative infinity, and then it's up to positive 3 on y. Now here's the thing, with domain and range, 3 was included in that highest point. So we've got to put a bracket here. So that brings me back to increasing and decreasing. There's no brackets with that because once we walk up the hill and now we're standing up here on the hill, we're not increasing, we're not decreasing. So we can't put a bracket and say, well, it's increasing at 3 because it's not. At negative 3 because it's not. It's not increasing or decreasing, you're at the top of the hill. Yes. Yeah, domain and range, yes. Yeah, but once again, yes, with infinity, it's not a number, so that's why we use parentheses. Okay, let's do another one. So everybody, look, technically, there's no min, because doesn't it grow down to negative infinity? Technically, there's no max, because it grows up to positive infinity. So we're looking at relative min and max. So relative would mean like looking at the relative parts of the graph here. Isn't this my highest point and lowest point? So my max is at negative 3 up 2, and my min is at 1, negative 3. Okay, very good. Now our increasing, this is really gets people. I'm going to write that in because it helps. If you have these written in, and I highly suggest it anytime you're testing or doing it on the homework. Yeah, you're right. I'm just not thinking. I'm so sorry. I need to focus. Negative 3 up 2. And then over 1 down 3, right? Okay, so here we go. So increasing, aren't I increasing up to here? Yeah. And aren't I increasing from here to here? Yeah. Okay, cool. Now remember, you got to shift your thinking. Increasing is always x values. So we're coming in increasing from negative infinity up to what x value? Negative 3. And then we're also increasing, so this is how they write, if there's 2, they'll do like a union sign. So, and united with 1 to infinity. Does everybody agree? Shift your eyes, it's x values, 1 to infinity. Now decreasing, we're decreasing on this interval. So from this x value to this x value. So we're decreasing from negative 3 to 1. My domain is in general, all together, where's my function growing from left to right? Yep, it's going this way forever and that way forever, negative infinity to positive infinity. Now my range, isn't it growing to negative infinity? And positive infinity. So range is all real numbers as well. Either one. Okay, all good? All good? Okay, looking at this one. This is going to happen. We have a max, we have a max, we have a min. Okay, we have 2 maxes. So one max is at negative 4 up 4. Another max is at 2 up 4. Very good. My min is at... Okay, now increasing once again to that x value and to that x value, right? Between those x values. So we're increasing from negative infinity up to negative 4, and then united with negative 1 to negative 1 to 2. And now we're decreasing from here to here, from that x value to that x value, so negative 4 to negative 1, and then we're also decreasing from 2 to positive infinity, because remember it's x values. It's easy though, it's so easy to get it, to let your brain switch, so don't blame yourself. Okay, domain, where's your function going from left to right? Negative infinity to positive infinity. And my range is negative infinity up to 4. Negative infinity up to 4, bracket, parenthesis, right? 4 is included. All good? Okay, so now, here's the thing though. You're not always going to have, all of those had perfect whole number points. You're not going to have some, all of them are not going to be perfect whole number points. So I have a min and I have a max. But that max, I can't really tell exactly where that's at. We're just going to use our calculator to do that. So I'm going to show you how to use your calculator. Pull that out. So, go ahead and follow me through this every step. You get lost and it's just a nightmare. Okay, everybody go to y equals with me. It was negative x cubed. So go to y equals. Now type in, now if you're going to type in negative x cubed, since it's in the beginning, you've got to use negative sign. So negative x raised to the third. So right here, caret 3. But then it was plus 2x squared, right? Now, if it was minus, you would use the minus sign, but it's plus. So plus 2x squared. I think it was 2x squared, wasn't it? Yes, okay. Plus 2x, and you can do caret 2, or right here's a squared key. Is everybody at least at this point with me? So this next part's where people get lost. Okay, here we go. Hit graph. Yeah, plus 2x squared. Yeah. It's your window, I'm sure. So we'll talk about window in a second. Okay, everybody ready? Listening. Now hit graph. Now everybody, this is what confuses people, and you have to be really good at understanding how your calculator works, because you're going to have to change your window depending on the problem. So everybody, do you see how I can see the dips pretty good? But I'm pretty spread out. I could get in there closer and see better. Now there's going to be times when you can't see enough, so you need to zoom out, and there's going to be times you need to zoom in. Don't use the zoom key. What you're going to use is you're going to change your window to your best benefit. So everybody, right, here's the window key. Let's go to window and get in there closer. So everybody hit window. Understanding the window is the hardest part for students. So listen so you understand what's going on. So this x min means, see how mine says x min negative 10? That means, look up here, if you were seeing your picture, that means you can see down as far as 10 tick marks on x. Negative 10, you see? And x max means as high up as you can see, we're seeing up to 10 on the x-axis. So x scale just means, what do you want your tick marks to be in? 1s or 5s or 10s? So we want to go in 1s always. So x scale we always leave as 1. Y min, once again, means how far down you can literally see on the y-axis. We can only see down as far as negative 10. And then y max, we're seeing up as high as 10. Do I need to see that far down? Not really. Can't I, like that, we can cut this off better, can't we? If we wanted to get in there closer. So here's what we could do. Do we need this much space for x? Not necessarily. So we can make our window smaller. So I'm going to go to x min and maybe change it to something a little smaller so I get in there closer. So I only have 5 tick marks showing. So x min I'm going to change to negative 5. If you ever see error, a lot of times it's that you've accidentally typed in a positive for x min or a negative for x max and whatnot. So x max, I'm going to just make it 5. Now, they don't have to be the same. They do not have to be the same. So I can leave that as negative 10 and 10 and graph it, and that's fine. But I'm actually going to go down to y and make y smaller. But I'm going to just show you, really, you do not have to have them the same. So I'm going to do down on y min, I'm going to go like negative 3. So I'm really zoomed in. And then I'm going to do 3. Does everybody understand how it works? Because you're going to have to go out further sometimes. Now I hit graph again, and now look how I'm so zoomed in, I can see this very, very beautifully. Yeah, you just hit graph after you fixed your window. Okay, so now what I'm going to do is I'm going to have to find the min and the max. So we're going to hit, that's not us, yep, second trace. Everybody following me? Second trace. Now you have to decide, do you want to find the min or max first? It doesn't matter, but you have to know, because you have to know what you're doing. So let's just find the min first. Everybody agree? Okay, now what this is asking you, understand what it's asking you because it will make more sense to how your calculator is working. So left bound means, okay, your calculator is saying, I can find the min for you, but you've got to show me where the min is. Does that make sense? So left bound means go left of your min so I know where the min is. So do you see how I'm left of the lowest point? Anywhere left will work. Your left will be different than my left. It doesn't matter. Hit enter. Anywhere left of it. Now it says right bound. You're just showing your calculator between where is the min located so I can find the lowest point. So now we've got to go over and scroll right of the min. So do you see how I'm to the right of it? Anywhere right will work. So I hit enter. Now it says, do you want me to guess? You only have to hit enter one more time. Everybody good? We do want it to guess for us. So look at the point. Now this really throws people off. How many people's calculator just says 0, 0? Yeah, yours. Very good. So everybody, this is 0, 0. It's just my calculator is so advanced, it's getting way too technical. So here's how I know it's 0, 0. Do you see how this is 1.6 e to the negative 6? What that means is this. 1.6 times 10 raised to the negative 6. As a number, that's a scientific number, that's Move the decimal back, since it's negative, 1, 2, 3, 4, 5, 6 places. So that's giving me a way exact 0. Like 0, 0, 0, 0, 0, 0, 1, 6. Isn't that, let's just call that stinking 0. That's 0, okay? It's just your calculator's being so exact. Okay, so you would just put 0. Now look right here. That's 5.7 e to the negative 12. Move that decimal back 12 places, that's pretty much 0. So we're going to say to our calculator, stop being so technical here. All right, 0, 0. So this point was at 0, 0, everybody. Now let's do that again. Let's find the max. Here you go. Do second trace again. So we're going to hit second trace. Now we're going to find the max, which will not be 0. Hit enter. Now it says left bound. You've got to be left of the min. Do you see how I'm to the left of the max I meant? Right here's my max. I'm left of it, so I can hit enter. Right bound. You've got to scroll right of it. I'm going to make sure I'm to the right of the maximum point. Right there's my max, so I'm to the right of it. I'm good. Do you want me to guess? Hit enter again. We're going to say, okay, there's no e's, so these are just decimals. So 1.3, comma, 1.2. So my max happened at 1.3, comma, 1.2. Okay, here we go. So now let's do increasing and decreasing. So increasing, aren't we increasing from here to here? X values, 0 to 1.3, so it's just not as pretty, but it's the same idea. Decreasing from negative infinity up to 0. And then are we decreasing from 1.3 to infinity? And then my domain and range on this one, domain is negative infinity to positive infinity. My range is negative infinity to positive infinity. Cool. Okay, let's do another one. So everybody, in your calculator, let's see. Now there are times, look, this slows down, but it doesn't dip down. So that's not a turning point. Right, here's a turning point, and it's a max. So everybody, in your calculator, you would do second trace max. Now don't do min, because that would be wrong. There's no min. Okay, ready, go. You find it. Second trace max. So you do it. I'm not going to pull it up, and then you can know if you got it right. Do like 1 decimal, please. Okay. Yeah, that's right. 1.2, comma, 6.2. Is that what everybody got, roughly? Okay, cool. So now we could do increasing. We're increasing from negative infinity up to 1.2. And then we're decreasing from 1.2 to infinity, aren't we? And then domain would be negative infinity to positive infinity, or all real numbers. Our range, though, would be negative infinity up to 6.2, including 6.2. I hope I didn't forget that on my other one, to put an including sign. We just didn't do them. Okay, cool. Sweet. Now look right here. I'm not going to do this one fully, but I need you to understand. There's a max, there's a max. There's one min. So you would have to go through and do second trace max, left bound, right bound. You'd write that down. You would write the point right there. Then you would do second trace max, left bound, right bound. You would write down that. You have 2 maxes here. Does that make sense? Then you do second trace, min, left bound, right bound, and then write that down. And now you can answer it. Okay, just go to your homework ones. Oh, one more. You see how this one has no turning points? So you would say, you would not do second trace max or min. There is none. You would say strictly decreasing. So no max or min. So then are we decreasing from negative infinity to infinity? Increasing nowhere. Okay, perfect. There are times though when you've got to be really careful because there are graphs that are like barely turning, and so you might have to zoom in really close to make sure they're turning. Okay, sweet. Do 17 through 20 on the worksheet. 2-1. So, everybody understand, I have a lot of people ask me, am I solving or am I factoring or am I simplifying? You need to understand the difference. So everybody, this says simplify. Simplify doesn't mean factor. It does not mean solve. Simplify means do what I'm asking you to do. Every problem is different. So simplify could mean multiply, add, or subtract. Or do properties of exponents. So everybody look right here. When I say simplify, this would not be solve. Does everybody see how there's not even an equal sign, first of all? That's not solving. So simplify right here means multiply, because look, it's saying simplify. Aren't we doing this polynomial times this polynomial? Okay, let's go for it then. Negative m times 4m cubed is negative 4m to the fourth. Negative m times negative 8m squared is? Good. Positive 8m cubed. Negative m times positive m is? Okay, good. Now, everybody listen up. You cannot add things that are not alike. So this is an apple, an orange, and a peach. You cannot add them together. Does everybody understand? Some people in this class, I'm not sure if you made the connection in Sec 2 for this. So everybody look up here. If I have 2xy's minus 1xy's, how many xy's do I have? 1xy. Does everybody see how the apple doesn't change? Okay, so you just said that. You're right. 2x squared y's minus 1x squared y's is how many x squared y's? 1x squared y's. Is everybody watching? Did the apple change? So with adding and subtracting, it doesn't change. Multiplying, yes. Adding and subtracting, no. You can only combine like things. So let me try this one more time. 3x cubed y squared minus 5x cubed y squared is how many x cubed y squared? Negative 2x cubed y squared. The apple, you're going to hear me say it. The apple doesn't change, okay? All good. All good? Here we go. Which one? No, because the apple's different. Okay, so with multiplication, they're not connected. Addition, they are. So this is a negative 4m to the fourth. When we're multiplying, we're like, oh, they're not connected. We can split them up. But where we're adding, they are connected. Good question. Okay, here we go. Number 18. 3m6n cubes minus 5m6n cubes is how many m6n cubes? Negative 2m6n cubes. We do not change the apple. All good? Okay, do 23. Now we'll look at 23. Isn't this one addition? Yes. Here, let's do number 23. 9x cubed plus 3, and then this is plus 4x cubed plus 7. So it's just set up a little differently. So don't we just add straight down? Okay, 9x cubed plus 4x cubed is how many x cubed? 13x cubed. Very good. And then 3 plus 7 plus 10. Very good. And we're done. Okay, I'm going to give you a second to practice a few in 1 through 27 and ask for help on any of those before we do some more advanced ones. People will do on accident. They look at something like this on a test, and if you're not listening, you might do it. They see parentheses and they assume, oh, if there's parentheses, I'm multiplying. I had an honor student have a problem like this. They spent 25 minutes distributing all this out. Well, first of all, it's not multiplication. Isn't it? This polynomial subtract this. So just because there's parentheses does not mean it's multiplication. You've got to look. What operation is it asking me to do? Now, next thing that people get wrong is they forget to distribute the negative. So I strongly suggest writing in a negative 1 here. Does everybody agree? Now, I need you all to watch because a lot of people say, oh, you just distribute the negative, and they distribute it here. There's not a negative in front here, so that doesn't change. Everybody agrees? That is just the same, so let's rewrite it. Negative 12h to the fourth plus h. Now, I have people also confused. Okay, now I'm multiplying in negative 1 here. So let's go ahead and do that. Negative 1 times all that stuff. Negative 1 times negative 6h to the fourth is positive 6h to the fourth. Does everybody see how I'm writing this? Negative 1 times positive 3h squared. And then negative 1 times negative 4h. Now, we would not have parentheses anymore. Like, we've taken care of distributing the negative. So what happens is people will put back in parentheses and then start multiplying things, which is, I don't know where the confusion came in. Now, aren't we just combining like terms? Negative 12h to the fourth plus 6h to the fourth is, very good, negative 6h to the fourth. Negative 3h squared, oh, I forgot, no, I still got it there, I just wasn't looking. So we have negative 3h squared, right? No other h squared. 1h plus 4h is 5h's. We know we can't combine any of these. They're not the same. They're not like terms. Okay, next one. Subtraction is like the most missed one on the test, and we really don't want to be missing the caliber of the easy problem. This caliber of problem is very basic compared to advanced math, right? You don't want to be missing these little things. So everybody looking. We have this polynomial. Is it multiplication? No, it's subtract this polynomial. So we'll put in -1 here. And then we'll say, okay, that -1 did not change anything over here. I'm going to rewrite it. 3a squared plus a plus 5. Now we're going to take and say, I've got to multiply -1 through to both, and then I'll have taken care of all the parentheses. -1 times 2a is -2a. -1 times -5 plus 10. That's where most people forget to distribute, is that final negative. Does everybody agree? It's not plus 10. -1 times +5 is plus 5. Okay, let's combine like terms. 3a squared, right? 1a minus 2a's is how many a's? Yep, -1a or minus a. 5 plus 5. No, a lot of people get their brains, their eyeballs backwards here, and they go like this on accident. -5. But it's 5 plus 5, so plus 10. No, what happens more than you think because you're going quick. And so your eyes will just, so just be careful. Okay. 28. Guess what people do? They only put the negative with the 5. That would be wrong, wouldn't it? So anytime I see subtraction, I say to myself, oh, this is a red flag problem. I've got to be careful. So we got to put a -1 here. -1 times 5n is -5n. -1 times +2. -2. Now everybody listen. Should I now, am I going to double dip on my negative if I put the negative in again? Yes. Haven't I already distributed the negative? So I'm good. Now I just add straight down. 11n minus 5n is 6n. -4 minus 2. -6. Okay, awesome. Do some more advanced ones. Okay, go to page 3. Notice at the bottom it has a page number. Go to page 3, problem number 1. Now on this problem, you'd say to yourself, what am I doing? Because once again, once people start multiplying, when they see subtraction, they'll accidentally multiply. So do you see how when I say simplify, you'd say, okay, what does simplify mean? Well, in this one, it's multiplication, right? Here we go. Let's do this. 5b times 5b. Perfect. 25b cubed. But as you can see, it's so easy to make one little error. 5b squared times +7. Okay, good. And now we'll cross that out because I've taken care of that. I'm going to change colors. 7b times +5b. Very good. And +7b times +7. And now I'm going to cross that out because I've taken care of that. Changing colors. -3 times 5b. Yep, minus 15b. And then minus 21. Now let's combine like terms. 25b cubes, no other b cubes. Cross it out. And then plus 35b squared plus 35b squared. Plus 70b squareds. And then we have plus, so 49b's minus 15b's is 34b's. And it's positive. That's a lot of things. A lot of times people will just mess up in one place. Make sure you're paying attention to positive versus negative. Minus 21. And done, right? Cool. Okay, last example here.
Whoa.
Right, now once again, this looks scary. But there's a minus and a plus sign. So is it really that bad? No, yeah. So once again though, but do you see how easy it is to kind of trick yourself into, now I've been multiplying things, I'm always multiplying things. So make sure if you were to unaccidentally multiply this out, you're going to be here all day. Okay, so watch very carefully. We have all this stuff. Is there anything in front to give us, make this changing? No, so I'm going to rewrite it. 10a cubed b squared minus 9a cubed b's. We cannot combine them. They're not apples to apples. That's an apple, that's an orange. Okay. A cubed b squared. This is an a cubed b. Can't combine them. Yep. Now look right here. We have minus all that stuff. Let's put in our -1 and distribute the -1 in. Right? But it's just going to be addition and subtraction, not multiplication down here. Okay, here we go. -1 times -a cubed b's is positive a cubed b. -1 times -11a fourths b squared is positive 11a fourths b squared. You're right. -1 times -8a cubed b squared, so positive 8a cubed b squared. Now look, it's not multiplication anymore, and then it never was, but it's not more multiplication. This was multiplication, anyways. And then we're adding all this stuff. Is that going to change all that stuff? No. So plus 6a cubed b squared plus 5a fourth b squared. And now we'll combine like terms. So let's start this out here. 10a cubed b squared. Any other a cubed b squared? 8a cubed b squared. 6a cubed b squared. 10 plus 8 plus 6. 24a cubed b squared. I'm going to cross them out so I don't miss anything. Now moving on, so negative 9a cubed b's. Any other a cubed b's? That one. How many a cubed b's? Negative 8 a cubed b's. Does everybody agree why? And then 11a to the fourth b squared plus 5a to the fourth b squared is how many a to the fourth b squared? 16a to the fourth b squared. And now we can't combine anything else. Now actually, technically, my answer is not written in standard form, and you could see this on an ACT. So technically, here's why. Now, listen, because this confuses people. Even though we know by properties of exponents, we actually can't add those, even though, because they're not the same base, right? But still, this would be considered degree 5. When you multiply, you add. So this is still degree 5. So this is degree 4, and this is degree 6. So let's reorder this in standard form. 16a to the fourth b squared, positive, and then it was, this one comes next, plus 24a cubed b's squared, and then minus 8a cubed b's. And then if they said to you on an ACT, what's the degree of the polynomial? There's going to be these options for you. And it tricks people. 4, they have the option 2, they have the option 8, and they have the option 6. Which multiple choice, if I said to you, what's the degree of this polynomial, you would call it degree 6. You would be right. Right? Highest degree. All good? Okay. Now that's different than having this though, right? 16a to the fourth plus b squared. Isn't this one degree 4? Okay, good. Just making sure. Okay, very good. You guys got it. That's it. That's the end of the lesson. Work until the end of the hour doing homework. Ready to go.